For over 25 years, Can Blast has been involved in the design, manufacture, supply, and repair of pneumatic loading equipment for the explosives and mining industries. Throughout this time, cartridge loaders have been the mainstay of this business, and our high-quality standards and improvements have made them popular throughout the world. This continual development and focus on improvement have encouraged us to create this video to help our customers with the correct setup and operation of these machines. Speed, convenience, and the ability to readily achieve high loaded densities have made bulk products the preferred explosives in mining and other industries. However, special conditions such as wet boreholes and upwardly sloping holes require the use of other products, such as cartridged water gel and emulsion explosives. Although these products provide excellent performance, the manual loading methods commonly used with cartridged explosive have several significant disadvantages. Manual loading is a relatively slow process compared to the mechanized loading of bulk explosive, because the cartridges must be manually tamped with a loading pole to ensure adequate compaction. The use of a loading pole also places a practical limit on the length of hole that can be loaded. Furthermore, this technique is unsuitable for use in upholes. Another significant problem is the level of compaction and hence loaded density that can be achieved by manual loading of cartridged explosive. Typically, manual loading of cartridges achieves only 60% of the loaded density achieved when bulk explosive is mechanically loaded. Since the need to use a cartridge product is often not discovered until after boreholes are drilled, as for example when holes are found to be wet, it is clear that borehole spacing based on loading of ANFO is likely to prove unsatisfactory for the 60% powder factor achieved with cartridges. This can result in poor fragmentation, low yields, and hang-ups. Mechanical loading of cartridged explosive using Can Blast loaders provides an efficient and convenient solution to these problems. Cartridged explosive is simply inserted into the breech of the loader and is propelled by compressed air through a loading hose and into the borehole. This allows for fast, efficient loading in an operation that is similar to the pneumatic loading of bulk explosive. Setup of the Can Blast loader is quick and simple. After mounting the loader on its tripod in as nearly vertical a position as possible, the required length of grooved anti-static loading hose is connected. The hose should be free of kinks or damage, and long enough so that its movement will not affect the setup of the loader. Blow out the compressed air lines to ensure that they are free of dirt, rust, or condensation, and connect the air supply to the loader. Finally, flood the breech with water and cycle the loader with the external trigger to flush the water through the system. Check to make sure that the slitting tack is in place, 1.5 to 2 cartridge lengths from the end of the loading hose. Also, cut a small V-groove notch in the end of the loading hose to accept the lead wire's detonating cord or shock tubes. This recess protects the lines from damage due to abrasion. Make sure there is a sufficient supply of clean, round, undamaged explosive cartridges of the correct diameter for the loading hose in use. Anti-static loading hose is available in 3 sizes to accommodate 1 inch, 1.25 inch, and 1.5 inch cartridges. Lubricate the cartridges before loading by spraying water into the open cartridge boxes. Ordinarily, holes are toe primed. That is, the detonator is placed at the bottom of the hole. This is accomplished by inserting a blasting cap or detonator into a primer stick or cast booster and placing it in the end of the loading hose. The loading hose is then pushed to the toe or end of the hole and loading commences. The air pressure and subsequent cartridges will push the primer out of the hose, and the slit cartridges will compact around the primer, firmly embedding it in the hole. Once the hole is primed, simply continue loading by dropping cartridges into the breech of the loader. backing the loading hose slowly out of the hole as the cartridges are loaded. Special conditions, such as very long holes or heavily jointed or faulted rock, may require multiple priming. This is accomplished by withdrawing the loading hose at the required level, placing the additional primer in the end of the hose, and inserting as before. In very severe loading conditions of broken ground, dynamic water, or to reduce dilution and overbreak, a detonating cord tracer is sometimes used to provide continuous priming. This is accomplished by tying a knot in the end of the detonating cord, placing the cord in the notch of the loading hose, and inserting the loading hose into the borehole. A detonator may be taped to the detonating cord anywhere along its length. The first cartridge to emerge from the hose embeds the knot at the toe of the hole. Side initiation with detonating cord results in some energy loss, making it a useful technique in wall control as well. Can-blast cartridge loaders are straightforward in design and provide trouble-free operation if correctly operated and maintained. The loader consists of a cast cylinder with pivoting flaps at each end and an air supply control valve. When the control valve is in the resting position, air is routed to the loading hose and air pressure holds the lower flap closed. In the absence of air pressure in the body of the loader, the upper flap remains open. When a cartridge is dropped into the loader, it activates a trigger on the control valve, switching air pressure from the loading hose to the loader body. This pressure forces the upper flap closed and allows the lower flap to open. As the cartridge drops past the lower flap, pressure switches back to the loading hose, propelling the cartridge down the hose and allowing the body of the loader to depressurize so that the next cartridge can be inserted. If a cartridge fails to exit the loader body, usually due to a damaged or out-of-size cartridge, the loader can be recycled by means of the external trigger. It is essential that only approved loading hose of the correct size be used. Unlike the ordinary plastic hose that may be similar in external appearance, loading hose is manufactured with rifling grooves on the inner surface to help reduce cartridge friction. In addition, approved hose uses an anti-static formulation to prevent the buildup of static electricity. The loading hose must be kept free of kinks or damage, which could impede the passage of the cartridges. Since the vast majority of problems that are encountered in the field are due to damaged loading hose, trying a new length of loading hose is recommended as the first step in troubleshooting. It is also important that cartridges of the correct size and in good condition be used. If cartridges have been stored in unheated conditions in winter, allow them to reach normal temperature before use to ensure smooth loader operation and for optimum compaction and adhesion in the borehole. It is also important to use the recommended operating pressure. Increasing the pressure beyond the recommended value will impede the operation of the loader by preventing the flaps from operating correctly. Excessive air pressure is also likely to cause problems with explosive wastage due to blowback, as well as subjecting detonators to velocities that are considered unsafe. The can-blast cartridge loader provides numerous advantages over manual loading of cartridged explosive. Holes up to 200 feet are easily loaded. Submerged holes and upward-sloping holes are easily and quickly charged. Holes in jointed or faulted rock can be loaded without difficulty and with excellent uniformity and compaction. Improved compaction is one of the major advantages of the can-blast loader. This can result in expanded patterns and translates into greatly reduced drilling cost and improved productivity. The speed and ease of loading provide a further advantage. Can-blast cartridge loaders have helped improve productivity in underground mining for many years. In addition, can-blast loaders are finding increased use in surface applications such as trenching, where their ability to quickly and effectively load through overburden, particularly under wet, broken, or other difficult conditions, can result in dramatic cost savings. Can-blast maintains a full inventory of loaders, loading hose, and replacement parts for quick delivery. For further information on how you can improve your blasting productivity and cut costs, contact Can-Blast.